Okay, for this lesson, you are going to prove that triangles are congruent by the SAS or HL. SAS stands for side, angle, side. HL stands for hypotenuse, leg. So we're going to go over both of those theorems. Well, one's a postulate. First thing they have I want you to look at this picture of these pencils. You can see they've put them together in such a way that they form a triangle when you draw this line at the back of it. When you have two sides that have the exact same length, which in this case would be this pencil, then you know that the angles okay, so I'm going to read this. Anytime you form an angle of the same measure with the pencil's sides, the side formed by connecting the pencil points will have the same length. In fact, any two triangles formed in this way are congruent. So this is where we're going to get our side angle side, because we have this side, this angle, and then this side. So when you compare it with another triangle formed in the same way, then you'll be able to prove it by side angle side. Let's look at the postulate to help. Okay, postulate 20, make sure it's in your journal. Side angle side congruence postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the two triangles are considered congruent. So you look here, you have RS is congruent to UV. We have angle R is congruent to angle U, and then side RT is congruent to UW. Because of that, we can say that triangle RST is congruent to triangle UVW. Because if these these two sides and this angle are all congruent, then that means this side is going to be congruent to this side. Because this angle has to be congruent, that means I can't widen this triangle at all. So this side's going to have to stay the same. Does that make sense? Okay. So you're going to use this postulate to prove. Let me take a picture of this shape. Okay, so we have two triangles here, and they want you to prove that triangle ABC is congruent to triangle CDA. So looking at the triangle, what would be our givens? Okay, we're making a two-column proof statement and reasons. So the first one is the given. What's one of the givens on here?
B, C, and A.
Yeah, BC segment is congruent to DA. BC is congruent to DA. We know that because that little red tick mark, right? What else do we know? What do those little red triangles mean?
Parallel.
That they're parallel. So my second given is that segment BC is parallel to segment AD. This is also a given. Okay, so those are the two. Are there any other givens on there, or is that it? That's it, right? So we have two lines that are parallel. So when you see that you have two lines parallel, you know you're going to be using some kind of where we have alternate exterior interior angles because we have a transversal. Does that make sense? Where's my eraser? There it is. Okay, so you're looking at the AC being the transversal. So what do we know about some of these angles because of our transversal here? Can I talk about this angle and this angle? What would that be?
Alternate interior.
That's right. Alternate interior angles are considered congruent. So angle BCA is congruent to angle CAD. Oh, DAC, sorry. DAC, we have to write them in the same order. And those are congruent because of the alternate interior angle. I don't care if you shorten alternate. Alternate interior angles. Good, okay. What else can we label looking at this? When you're looking at two triangles that are laying on top of each other, what do you know about this segment, CA?
It's the same.
It's the exact same line, so we know that it's equal to itself. What's that called? Try not to look in your book. Okay, I gave you a hint with a mirror. If you're looking, reflexive, like a reflection. Okay, so we know that segment AC is congruent to CA because of reflexive property. It takes time, guys. Don't feel bad that these don't come to you. They still don't always come to me, and I've been teaching this for a long time. Okay, so now, do we have enough information? We can use we can use our new postulate, because we just proved now that this line is congruent to itself. So now I can say side, angle, side, can't I? So we're going to say triangle ABC is congruent to triangle CDA. I can't write today, I'm having problems. Because of side, angle, side. So sometimes you have to prove two things before, like we proved that that was reflexive, and we proved that these two angles were congruent because of postulates and theorems. And then you can use the side, angle, side. What the nice thing is, in your homework, I'm not going to make you do a big, huge proof like this. You're going to be able to tell me yes because of side, angle, side, or no because of because it doesn't work. We'll go over hypotenuse length. So. Okay, let's look at, that was example 1. Let's look at example 2. We have a funky picture here. All right, so we have a circle, but within this circle, what do you see? We see two triangles. We have this triangle right here and this triangle right here. Right? They're asking you, well, first they tell you QS, so this length right here. Here, we'll use my other color. QS and RP pass through the center, M, of the circle. So those are directly in the center. What can you conclude about triangle MRS and MPQ? Well, let's see. I'm assuming they're wanting to see if side, angle, side works here. So let's see if we can prove side, angle, side. First, let's look at the angles. Can I prove that those angles are the same? What's it called?
Vertical.
Vertical angles. So we can already tell you that because angle PMQ is congruent to angle RMS because of vertical angles. Okay? Now, let's look at these points on here. It told us that M was directly in the center of these points. So the distance from here to here is what compared to here to here?
The same.
It's going to be the exact same distance because we know that the M is directly in the middle. So I can say that this line is congruent to this line is congruent to this line. So at the end of the day, because all points are equal distance. Then we know that the triangle MRS is congruent to triangle MPQ because of side angle side. My picture got very colorful. Any questions on how we worked through that? Not too bad, right? Let's look at your next theorem. Okay, first of all, you got some new vocab today. When dealing with right triangles, and remember, this is specific to right triangles. I can't draw a straight line to save my life. Okay, so even though it doesn't quite look straight, it is. This diagonal line on the outside of the triangle is called what? Hypotenuse. 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 Once you have identified the hypotenuse, can you tell me what each of these is called?
Leg.
Yeah, those are considered the legs. They will always touch the right angle. And the hypotenuse will always be directly across from the right angle. Okay, when you're dealing with right triangles. Okay, so there's some vocab words for you. So now let's look at the theorem. The hypotenuse leg congruence theorem. If the hypotenuse and a leg of the right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the two are congruent. So let's analyze this, look closer. We're talking about the hypotenuse first. So if this side and one of the legs, does it matter which leg? No. And one of the legs, as long as it's the same leg on both triangles, are congruent, and we already know that this angle is congruent, then these two triangles will be considered congruent. Okay? If you look at that, that's side-side angle. Side-side angle. The difference is we're dealing with right triangles here. So you call it the hypotenuse leg. Okay? Not side-side angle. Make sense? So far you've learned, what was the first one we learned? Side, side, side. We just learned side, angle, side. Instead of doing side, side, angle in a right triangle, it actually is hypotenuse leg. I'm going to give you a hint. You will never have angle, side, side. Well, Gwen got my joke. You will never have angle, side, side. This will never be in your geometry. All right, there's the smiles. Okay, good. Got it. What makes me laugh is when my mother says that joke too, and I'm like, Mother. All right. Let's look at example 3. All right, so you have this funky diagram, funky shape with two triangles in it, right? Mm-hmm. So we have one triangle here and one triangle here. I'm a pretty visual learner, so I'm going to separate these two triangles so that I can mark them up. So my first triangle was similar to this. Does it have to be perfect? Absolutely not. And my second triangle was like this, right? When you're looking at this, what do we know about some of the sides and some of the angles that are true? What do we know about this one? It's reflexive. So that means I can mark on these two triangles that this segment equals this segment. Okay, are there any other things we can prove? If I go, let me use another color. If I go from here and go this way,
Is it a right angle?
it's perpendicular is what you need to be saying. So I can say that, I'm going to have to do statement and reasons here. I'm going to run out of room maybe. Statements, reasons. So one given, whoops, that wasn't the reasons. Is that WZ is perpendicular to ZY. Okay, and the other one we know is on the other side. XY is perpendicular to ZY. Okay, and then we already did the first one, which was ZY is congruent to YZ. And this is a given. Actually, this one's not considered the given. I apologize. The other one that they're giving you is that we know this segment is congruent to this segment. So they're telling you this already. Okay, so that's the next given. You're going to say WY is congruent to XZ. And they told you this. It's not something you can look at the diagram. So this is my next given. All right, so we have all kinds of colors on here. I'm going to erase it so we can see it a little bit better. Okay, so they want you to prove that triangle WYZ is congruent to triangle XZY. So my next statement, what do we know? If this is perpendicular to this, what do we know about that? Because it told us that they were perpendicular, and you said it to begin with. They are, it's considered a right angle. So we know that angle WZY and angle XYZ are right angles. Are right angles. And we know that because the definition of a perpendicular line. If it's perpendicular, then they're considered right angles. You remember that? Are you stealing her charger?
No, it's asking.
Okay, there's another one here. If you want to plug it in, you're welcome to. Okay, what else do we know? Since we know that this is a right angle, we know that these are what kind of triangles? Right triangles. So number 4, triangle WZY and triangle XYZ are right triangles. I'm running out of room. And this is also because definition of a right triangle. If you have a right angle in a right triangle, it's a right triangle. Okay? We had already written it, but we didn't, it wasn't a given. But now we can talk about these two lines, this line right here. Hold on, let me grab my other marker. The ZY is reflective to YZ. I'm going to go to the next page because I'm out of room. Why? Because if you look on here now, we have side angle. No, we don't. We don't have that angle. We have this side, and we have this angle and this side. So that's that side-side angle, which doesn't actually have side-side angle in a right triangle. It's considered a what? So, statement, reasons. This is number 5. We can say that ZY is congruent to YZ because of reflexive property of congruence. And our last statement is triangle WYZ is congruent to XZ hypotenuse length. So number 6 is a hypotenuse length theorem. Good? Any questions on how to do that? Most of what you're doing in your homework is for the first part, you have a little diagram and they want you to name the included angle between the given pair. So if I have a triangle and I tell you the name of this side and the name of this side, which one's the included angle? This side or this side? This is angle 1, 2, 3. Which angle's included if I give you these two sides? The included angle is the one between the sides. So this is considered your included angle. So that's what we're doing for the first little bit. Tell me which angle is included after you tell me which two sides. It's the one that forms the point between two, okay? And then you're just going to tell me whether the information they give you on a diagram is enough information to prove side angle side. So side angle side has to have a side, an angle, and then another side to prove that it is congruent to another triangle. Okay? So you'll just say enough or not enough. And then the last part of your homework is to use the postulates that you've been taught to tell me what segment it's congruent to. If you're confused, just come ask me. I'll help you. So you're doing numbers 3 through 14 and 25 through 28.